Hello, and welcome to G Fun Facts Online, where we look at the universe's biggest and brightest mysteries. Today, we're talking about explosions. But not just any explosions. Forget supernovae. We're talking about something so powerful, so bright, it outshines 100 supernova combined. These are the most energetic cosmic fireworks discovered since the Big Bang itself, and they're powered by one of the most terrifying things in the cosmos: a supermassive black hole having a meal. For a long time, we thought supernovae were the final word on spectacular star deaths. But astronomers have now identified a new class of event, dubbed extreme nuclear transients, or ENTs. Imagine a star, maybe 3 to 10 times the mass of our Sun, just wandering through its galaxy. It gets a little too close to the galactic center, where a supermassive black hole is lurking. The black hole's gravity is so immense that it grabs the star and shreds it to pieces. This process is called a tidal disruption event, or TDE. You might have heard of spaghettification, where an object is stretched and compressed into thin strands. That's exactly what happens to the star. While we've known about TDEs for a while, these new ENTs are on a whole different level. They can be nearly 10 times brighter than a typical TDE. The energy they release is staggering. In just 1 year, a single ENT can blast out the same amount of energy our Sun will produce over its entire 10 billion-year lifetime. That's an almost unimaginable amount of power. What's also fascinating is how long they last. A supernova explodes and fades within a few weeks. An ENT, however, takes over 100 days just to reach its peak brightness, and then over 150 more days to dim to just half that peak. They can stay luminous for years. This sustained glow acts like a cosmic spotlight, illuminating the otherwise dark and inactive supermassive black holes at the center of distant galaxies, letting us study them like never before. So, if these events are so bright, how come we're only just classifying them now? Well, the universe is a dusty place. Many galaxies are filled with cosmic dust that can block the X-ray and optical light these explosions produce, hiding them from our telescopes. But scientists at MIT had a brilliant idea. The same dust that blocks the light also heats up and radiates that energy away as infrared light. By searching for these events in the infrared spectrum, the team found a way to peek through the cosmic dust clouds. Using this new technique, they recently discovered 18 new TDEs, more than doubling the number we previously knew about. This suggests that these star-shredding events are much more common than we thought, happening in a galaxy maybe once every 50,000 years. Finding more of them, and in a wider variety of galaxies, helps us build a complete census of TDEs and understand the supermassive black holes that cause them. And because these ENTs are so incredibly bright, we can see them from across the universe. Looking far away in space is like looking back in time. By studying these events, we get a glimpse into how black holes were growing when the universe was just half its current age, a time when galaxies were much more active. Recent observations have given us even more detail. A TDE, named AT2022 LRI, showed a black hole feeding at a rate so high it should be unstable, with its X-ray brightness dipping dramatically on timescales as short as half an hour. Another event, AT2024 TVD, gave astronomers a huge surprise. TDEs are supposed to happen at the center of a galaxy, where supermassive black holes live. But this one was offset from the center. It's the first evidence of a TDE caused by a wandering supermassive black hole, one that isn't anchored to the galactic core. The future of this research is incredibly exciting. Upcoming observatories like the Vera C. Rubin Observatory and NASA's Roman Space Telescope are expected to find thousands more of these events. Each new discovery is a piece of the puzzle, helping us understand the physics of black holes, the life and death of stars, and the evolution of entire galaxies. These extreme nuclear transients aren't just cosmic light shows. They are powerful probes into the most extreme environments in the universe, changing our understanding of how the cosmos works. Thanks for listening to G Fun Facts Online.